Welcome to another Big Daddy D Adventures. Today we're actually having a project adventure. Wanted to show you guys one of my solutions for steel storage in my shop. I do a lot of metal and I also do wood, but this is a vertical steel rack that I put together based on what I had in the shop. What you see here is you see a base down across the bottom, and then I have one, two, three, four, five different bays. I have square, I have rounds, I have angle and channel, and I have flats, and then I have kind of a miscellaneous over there. And basic structure is, I got a big base down there. I got a piece of plywood decking it. I also have 2x4s cut down to the same height as that 3-inch schedule or 2.5-inch schedule 40 that I have along the bottom there. So it's a filler underneath that plywood, so it's the plywood is supported by the wood onto the floor. And then over here on the back side I have an 1.5-inch square tubing. I think it's a 120 wall. I have to confirm that. And I got one of those on both sides. And then around back here, if you can see, I got one pipe down here as a cross member that supports the pipes that kind of separate the material. And then up here at the top I've got another pipe going across there sitting at 8 foot. And then what I did is I came in here, I think this is about a 30-inch gusset. Comes out 30 over and 30 up. It's on a 45. I put that in there to kind of help relieve some of the stress of that weld down there at the bottom, on the bottom of these verticals. So that is an overview of what I built, and stay tuned and I'll kind of walk you through how I got to this point, how I did the design, how I did the drawings, and we'll see how it goes. Hopefully you stick around, and at the end I got a little bonus. The bonus is I'll kind of walk you through how I store the rest of the steel in my shop, because this is just one of the solutions. Take care. Bye-bye. So this section, I want to walk you through how I normally build stuff in my shop. Usually it starts with some kind of a sketch similar to this. I start with kind of drawing a basic shape of it. Here you have a side view, here you have a front view, and then add a little detail sketch on the bottom of the base. Then after I come up with that basic sketch, then I look for what steel I either need or what steel I have in my shop, and then identify the materials list and kind of round numbers just to kind of confirm that I have the metal or the materials that I need to build it. This is an idea of a sketch that I have for this vertical rack. So after I have my sketch, then in some cases I just do, machine shop or workshop kind of a stress test. Let me stand on it on the floor. Does it flex? Yes or no? Okay, it should be good enough. In this case, I didn't do it. I probably should have, but we're going to do it now. Tried to figure out, well, what is the load case for this rack? So for this load case, I kind of made a simplistic little model here. The little blue thing is the steel leaning up against the back, thinking that the FG is, what is the force of gravity pulling down that steel, and then the FR up on the upper right, that's the, what does that rack need to resist? And then based on the angle that the steel is leaning up against, I should be able to find that ratio. In this case, tangent is equal to opposite over adjacent, and just filled in the numbers here, where FR, the ratio FR divided by FG. Again, that's what is that resistive force, and then that force of gravity from the load. That ratio should be the tangent of that angle that I measure. So in this case, since I already have a rack and everything's already built, I have the relationship between the, how much I put on the rack versus how much force that rack needs to resist. What I did here is I did some simplified stress calcs, simplified for some, but anyway, what I did is I figured out my load case for the bending down at that point A, And based on the yield strength of the steel at 36 KSI, which was my assumption here, came out with a FR max of 211 pounds around there for those 2.5-inch uprates. And then now that I have that, then I can go back and plug in for different angles there. I can plug in the angle based off of this being the max, and I can find out what is the range of steel that I can load onto this rack. So if you look at the chart down here on the bottom right of the screen, you see if I have an angle of 5 degrees, which means those things are almost standing up vertical, I can put a lot of weight on this rack without the back part of this failing. Where I currently sit is probably around between 8 and 10 degrees, so it should be capable of handling between that 1,200 and 1,500 pounds of steel that I currently have on the rack, which is actually more than I have had on that rack in a long time. So I think I should be pretty safe here. So main thing is rack is currently loaded with about 1,200 pounds of steel. Seems to be holding, so my engineering calcs must have not been too far off. And I am assuming also that that steel is evenly distributed between those uprights for me making the assumption that just count them as 2 uprights that are right next to each other. From a safety standpoint, one thing I did not include in these basic calcs with those big gussets. By adding those big gussets, it really takes away a lot of that stress on that weld. So that's a big safety factor. And the biggest risk I was worried about the thing tipping over, but since the center of gravity, everything is over the base. Should not be anything pushing it backwards. And then also big thing is I have it against the shop wall, so if it did fail, it would hit the shop wall before it would hit me. So the only other thing to consider here is, would I change anything? Would I do anything different? And, after doing that sensitivity analysis on that angle, I might add a little wood stop and mark that when I start loading that rack to make sure that I'm not going too far back on that steel, making sure it's close to vertical or within that 10 degrees. The other thing is I might add a safety chain or a hoop up near the top. That way, if I do get it too vertical and it decides to fall out, it wouldn't hit me. But hopefully keeping around that 10 degrees, it won't be a problem. The only other thing I can think of is if I had extra steel at the time, of course now I do, but I might add an extra vertical tube in the back to evenly distribute across the 3 square tubes instead of 2. That's about it. Well, thanks for hanging around till the end here. Wanted to go ahead and show you a bonus clip. This is what I do with the rest of the steel in my shop, how I handle everything under that 3 or 4 foot range, and how I handle my 20 footers. So here we go. Welcome back. I want to share the rest of the steel in my shop. So I've got my vertical rack over here that handles my 8s, 10s, 12s. I think I try to keep them 3 or 4 foot over here on this rack. So anything 3 or 4 foot long, usually I'll keep on this rack. Then from time to time I'll buy 20s because it's cheaper to buy them, and then I end up with a couple of 20s here and there. Usually the 20s are on bigger projects, and it's usually just leftovers that I have. So I don't store a lot of 20s. A lot of times if I have leftovers, I'll chop them down to 10s and then put them on my other rack. But this is my current solution. All I did was I used some of these concrete blocks. These concrete blocks, and I put they're meant for like backyard decks and pier and beam kind of things. I just ran a 2x4 across them, and I put 3 of those over the 20-foot length, and then I just laid the steel on top of it. So that is my solution for my 20-footers. Welcome back. So the rest of the shop tour is, well, what do I do with anything that's 3 foot or less? A lot of 2s, a lot of 1s, and then just some small parts. So what I have here is I just bought a shelf. I think I got it from Home Depot. I went ahead and replaced the wood in it. I think I put some 3/8 wafer board in there. I also put some stiffeners underneath there. I put some extra boards underneath to help hold that load, and I screwed those into that frame. And then I also added some stiffeners here because it used to be quite wiggly. But yeah, I just use a standard shelf. I think it's a 4 foot by 2 foot shelf, and then wanted to move it from time to time, so I just added another deck down here on the bottom and put it on some furniture dollies, Harbor Freight specials. These are 1,000-pound furniture dollies. I got 2 of them on it. I don't have that much steel. I don't know if the rack would hold that much actually, but so I got the 2s, and anything 3 foot and 2 foot I got on this rack. Again, rounds, squares, flats and angles are together. And I got some solids up here. And then for the little bitty things, what I did is I came up on top and I put buckets. So I got a bucket for the angles, bucket for the flats, bucket for the rounds, and a bucket for the squares. So between these 3 racks that I got my 8 to 10 foot vertical, I got my 20 foot horizontal, and then my short rack. That is how I store the steel in my shop. Hopefully that helps inspire you. Well, thanks for coming on another adventure with me today. I enjoyed taking you with me, reviewing my vertical steel storage rack build and showing you how I currently handle the rest of the steel storage in my shop. I hope you enjoyed coming on this adventure with me and hopefully learned something along the way. As usual, if you like what you saw, give me a thumbs up. And if you'd like to go on more of these adventures with me, hit the subscribe button. As always, take care. Bye-bye.